In this problem, we're going to look at how to solve a triangle using the law of cosines. With the law of cosines, we can either know two sides and an angle to solve it, or we can know all three sides and solve for the angles. In this example, we're going to take a triangle with sides 8, 10, and 15. And we're going to solve for the respective angles. You'll notice that the law of cosines looks a lot like the Pythagorean theorem. In fact, this is a more generalized version of the same theorem. This works with triangles that are not right triangles. Let's first solve for this angle right here, which we will call C. We'll take our formula and write 15 squared equals 10 squared plus 8 squared minus 2 times a times b, which is 8 times 10, cosine of c. So we can now solve for what c is by evaluating this and solving for c. That gives us an angle of 112.411, which of course is not actually that accurate, but we will keep those decimal points around just in case for later, round it at the end. Now, in order to solve the other angles, we can take the same formula, and instead of writing out c squared plus equals a squared plus b squared and so on, we can shift all the letters one direction. So we can write a squared equals b squared plus c squared minus 2bc cosine a. Now, if this is, I'll put a right there, which means that 10 is little a. So in this problem, we can plug our numbers in again. Well, for clarity, let me write out the other way. We can also write out b squared equals a squared plus c squared minus 2ac cosine b. Now, using these, we can solve for each of the angles of the triangle. If we plug in the numbers for a, we'll find out a equals 38.047 degrees and b equals 29.541 degrees. The law of cosines, as I mentioned, is also useful for when we have two sides and an angle. We can solve for the other side and then the other angles.